Welcome to the March 2025 CIECA webinar, 3D Printing and Collision Repair. I'm Paul Berry, Executive Director for CIECA. The Collision Industry Electronic Commerce Association, or CIECA, develops and promotes electronic communication standards that allow the collision industry to be more efficient. We also provide webinars like this one to help educate both members and non-members on trends that impact systems, processes, and the exchange of data across the industry. Today's presenters are Harold Sears and Gerry Poirier. Harold Sears is the head of Advisory Council for Auto Additive. He has more than 36 years in the automotive industry, including 29 years focused on additive manufacturing while working with Ford. Gerry Poirier is a consultant with Vector Squared. He has over 50 years of experience in auto physical damage management, including roles with Hanover Insurance, AIG, and Farmers Insurance. There is no verbal communication between the participants and the presenters. If you have questions during the webinar, please type them in the question panel on the webinar screen, and we'll answer as many questions as possible at the end of the presentation. And now, I'll turn it over to Harold Sears.
My name's Harold Sears. I'm the owner of Imagine Additive Consulting, and I also work for a company called Hyperion X, where I'm head of advanced manufacturing. But in this role here, I am working with a company called Auto Additive, and I'm head of the advisory board. So I'm going to talk a little bit today about 3D printing in the auto repair industry, what we're doing as a company, Auto Additive, in this space. But what I wanted to do is, because I don't know the background of folks on the call here, I wanted to start out with a little history on additive. Some people think it's a new technology. I guess in the big scope of things, it is new. But for the sake of really looking at the technology, it's not that new. It's been around for a little while. So anyhow, we'll jump into that. One thing to note is this picture of this nice shiny Cobra car here on the screen. That body of that is actually 3D printed. So we'll talk a little bit more about some applications similar to that here in the future. All right. So first thing, 3D printing, kind of what is it? It's 3D printing is also known as additive manufacturing, and you will hear me use those two terms interchangeably. Both of them essentially stand for the same thing. It's really the process of creating a three-dimensional object from a digital file by laying down successive layers of material one at a time. So really the key concept is it's unlike traditional manufacturing technology shown on the top here, where you're removing materials. You tend to start with a block of material, you machine it, file it, drill it, whatever it is, you remove material to end up with your object. And then in the result, you have a pile of waste. But unlike that technology, you really just start with material and you use some sort of device or a process to add material together to make your final part. And then the good part of it is in the end, there is actually very little waste in the process. So as we look at where did this technology come from? In 1981, Dr. Kodama developed a technology to use UV light to harden polymers. So some people kind of consider that the first version of 3D printing. Some people will debate that. But really the first sort of machine to actually be able to make three-dimensional parts was developed in 1994 by Chuck Hall. Chuck Hall developed a technology that he referred to as stereolithography, or you hear it referred to as SLA quite often as well. And this was a machine that used photocurable polymers to create three-dimensional objects. And so he's really been considered the father of the technologies because he was the first one to really mechanize the whole process and make it somewhat automatic. In 1999, there were a couple of other key inventions that came into play. Fused deposition modeling, known as FDM, by Scott Crump. So the third guy down here in the picture, that's Scott holding some parts with some of his machines on each side. That technology is one of the most popular technologies in the world today. And then at the same time, selective laser sintering, or what was called SLS, was being developed by Carl Deckard here in the bottom picture. Unfortunately, Carl is no longer with us, but fortunately, both Scott and Chuck still are. And I know both gentlemen, great guys and really interesting to talk to. So these technologies there's really eight types of technology groupings grouped by and recognized by ASTM. And if we just walk through these real quick, just so you understand that it's not always just the printer that you see in people's houses or on desktops. That it's much broader than that. So the first one was it's referred to now as VAT photopolymerization, and that is really the technology that Chuck Hall developed, stereolithography. And so this uses a vat of liquid resin. A laser is deflected off a mirror down to the surface of the resin. The mirror moves around to direct the laser around, and wherever the laser hits the resin, it literally cures or hardens the material in that area. So after it does an entire layer, the build platform will drop one layer thickness down into the vat, and it will begin to cure the next layer of resin. And so that process repeats over and over to generate a three-dimensional object. The second process referred to as powder bed fusion. And this is really what Carl Deckard had developed, what was called selective laser sintering back then. But this basically uses a powder. It spreads a powder across the table, and then it uses, again, a laser that's deflected off a mirror down to the surface. But in this case, the laser actually melts the little polymer particles together to again form that 3D object one layer at a time. And when it's finished, you simply remove all the powder and pull the part out. Another technology is called binder jetting. So this one uses something similar to like an inkjet print head. So it starts with a powder substrate, and then it jets down what's known as almost like an adhesive onto that surface. And what that does is it binds the little pieces of material together, which is why it's called binder jetting. One of the advantages of this technology is that binder or glue that can be extruded out can be various colors. So you can literally make a part in several different colors. The next one is material jetting. So this one, similar to binder jetting, where you're using some sort of a jetting head or a print head of some sort, but instead of depositing an adhesive, it actually deposits the material directly in a liquid form, and then it's exposed to a high-powered energy source, which is usually a UV light, and that causes the material to harden and cure when it hits the surface of the material where it's being jetted onto. The next one is called sheet lamination. This one still exists, but it's not very popular anymore. It was one of the early technologies referred to way back in the day as laminated object manufacturing. But this one uses a media. In this case, it was a paper with an adhesive layer on it. So it comes in a roll. It was stretched across the build platform. A hot roller came across it to adhere the layers of paper together. Once it did that, then again, a laser was used down to the surface, but this time the laser actually cut the paper. So it was actually cutting out the shape of the 2D section. When it was finished cutting, it would lay another layer of paper down and cut the next one. So when it was done, you had essentially a block of wood with your part inside of it, but your part was cut out. So you just had to break the pieces of wood off separately to yield your part. The next one is material extrusion, and this again is the most popular technology out there. This is the technology that essentially Scott Crump developed and that he referred to as fused deposition modeling. Um, this one uses a material feedstock, which is generally a thermoplastic. It's heated up and it's extruded out of a nozzle down to the surface, and where it forms layers after layer to form your 3D part. It also uses a secondary material, which is a support structure, so it helps hold the parts in place while they're being made. This is the technology that many of you have probably seen from personal printers or small hobbyist type printers. Generally uses this technology. The next technology is called directed energy deposition, primarily used in metal 3D printing, where you have a high power energy source. It could be a laser, it could be electron beam. The material is then fed down into a focal point of that, and the high energy melts the material and deposits it onto a surface. Could be a part, could be just a substrate, could be any number of things to form a 3D part. And then finally, the last one, we just refer to that as a hybrid technology. And what that generally is a combination of other technologies. And most frequently, it's a combination of directed energy deposition, where the material is deposited to grow the part, but it's integrated with a CNC machine that then comes out and does some machining work to trim it up and clean it up and make a nice part. So when you're using a hybrid technology, generally when the part's done, you have a beautifully finished part in the end. So how does all these, professional technologies relate to what we're talking about in our application here? So what I'm showing here on the screen is an image from generated to demonstrate the power of HP jet fusion technology, and this technology would be used to make like several parts at one time. So in the case of this picture here, the way this technology works, it allows you to put many parts into a build envelope. As long as they're not touching in your computer model, you're pretty much good to go. But in this case, this example, there were 300 parts in this space. Those 300 parts built in about 11 hours, and if you break the math down on that, that's about 27 parts an hour, or one part every 1 to 2 minutes in that area. So that starts to give you an idea that, wow, this could be scaled up to higher volumes. It's not just 1 or 2 parts at a time. And then probably what would be a more practical application of the things that we've been working on is in something like this, where it's a variety of different parts, not just all the same part. There's a huge variety of parts. There's 140 parts packed into this build. And again, this build would take the same amount, about 11 to 12 hours to build and tear apart. After that, you would have all these parts that are ready to go. So it really starts to demonstrate how the technology has evolved from just making one part in the early days, very fragile, tight parts that could be broken or destroyed very easily, to now parts where you can make many of them at one time, and they're made of very robust materials that are highly usable. So as we start to apply this to automotive applications, this is just a high level chart of some of the more popular automotive companies that are employing additive or 3D printing technologies now in their process. And their application of these technologies can really be anything from a concept prototype from some companies to production parts that are going on customer sellable vehicles with other companies. And so we'll talk a little bit here now about that and how some of them are applied. In this portion of the picture is some examples from Cadillac. These were some ducts that were made along with a wiring bracket. And this piece is actually the shift pattern that goes on top of a gear shift lever. And this is actually 3D printed in metal. So it's a really nice looking part and nice accent to the interior of the car. This example are customized brake and clutch pedals for a vehicle. In this case, it was a performance application where weight really mattered. So these were actually 3D printed in titanium. And so you can come up with some very exciting lightweight shapes and still have the structural strength that's needed for the application. Another thing that a lot of folks don't think about very often is not just the direct use parts, but parts or tools to help in the assembly of vehicles. So in this example, in the upper right-hand corner, it's a tool that's used to help prevent damaging this wheel while the lug nuts are screwed in. Down here in the lower left is an application from Ford Motor Company. So this was a brake line bracket. There's 2 of these on every Shelby GT500. And this used to be a metal part, and there was a unique left-hand and right-hand version of it. It was redesigned into one version that could sit on either side of the vehicle and printed in plastic. So it was a great cost saver and a tool eliminator. This is another example from Ford of a 3D printed metal wheel locking lug nut. And what's neat about this is this pattern is that's in the lock. You can print the lug nut itself. You can print the key for it with the same pattern. The pattern can be computer generated, so it's totally randomized, or you really could do a custom pattern here too for somebody if you want to do some branding or something like that. So that was a pretty cool application. This application has received a lot of airtime over the last few years. This was done by BMW, and this was a tool to apply badging to a vehicle. This tool traditionally was cut out of aluminum. It was a billet machine tool, so it was a very expensive tool, and it weighed several pounds. This is a 3D printed version out of polymer. It's very light and only weighs a couple of pounds. So not only is it much lighter and easier for the operator to work with, the less damage, less potential for damaging a vehicle while applying it. One of the things I really liked about this is that if you were an operator on the line, you repeat this process over hundreds and hundreds of times a day. So if you can be given a tool that weighs several pounds less over those 100 times a day, you appreciate that a lot and tend to be happier with your job and do a better job with it. So I think that's a great application of tooling. A couple more around automotive. The high-end Cadillac that was recently released had more than 115 3D printed components in it. So that's one of the highest number of 3D printed parts in a production car that I'm aware of. So that's pretty exciting. Good job to the folks at GM on that one. This one here was actually published a couple of years ago. BMW announced that they had printed their 1 millionth part, 3D printed part that actually has gone into a series production car. So that's a great milestone for that team. And BMW is one of the companies that's really pushed the technology to be more automotive centric than it originally was started to be. And finally, last application around automotive. This one was announced as well a few years ago. This was announced by Porsche, where they're actually approved the use of 3D printing of spare parts as replacement parts in classic cars, where the tools maybe are no longer available, or the company is defunct that used to be the supplier for this part. So certain parts, certain applications have now been approved. And you can basically just simply go to a website and order it. It is 3D printed and shipped to you. There's likely little to no inventory of this part sitting on shelves. So it's a great application. And we look outside of the automotive industry. There's 3D printing is just being used in various things all over the place. One of the things is very similar to what we're working with for automotive is Whirlpool announced a few years ago that they were starting to 3D print spare parts for Whirlpool appliances. So pretty exciting that once again they're not having to inventory and store tools. They're able to essentially print parts almost on demand. They probably have very little inventory as well. Off-road equipment, John Deere, big user of additive as well. They announced that they were 3D printing parts for a fuel valve on some of their big tractor applications. Very cool. Aerospace, Boeing, and some of the other aerospace companies are using 3D printing a lot, and a lot of the parts are going right directly on aircraft that not only military applications as shown in this picture, but also commercial aircraft as well. Another transportation company is DB, is Deutsche Bahn in Europe, the rail company. They have a whole additive manufacturing center that they use for printing spare parts for replacement parts on trains. So pretty exciting, all the applications, and I'm not even getting into some of the medical applications, which are just really amazing. You could do entire seminars and days worth of discussion and printing around medical applications. Super exciting stuff. So how did that all apply to the automotive collision and repair industry? Well, in 2023, I was asked if I would join an effort to lead an industry task force to study how 3D printing could be used in the auto repair industry, how it could benefit it, what were areas where it could be applied and things like that. So first thing we did is went out and really assembled a panel of folks that would be involved in this from sort of beginning to end kind of a thing. So folks that know the industry well, like Jason Mosley, former head of IBIS, and folks like Mario Demolsky from the Boyd Group, knows the collision industry very well. So they were on the team. Then we reached out to 3D printing companies, and Francois Menick, who was the head of 3D printing for HP, agreed to join. We had material supplier like Rebecca here from BASF. We had folks that deal with training and applications in the industry from ICAR, Jeff Peavy. We had people from 3M. We even had an OEM supplier on board, Dallas Martin from Toyota. And Dallas has been doing some great things to move 3D printing forward within Toyota. He was just recently in an article that was published, and amazing progress they're making in Toyota toward production with 3D printing. And then we even reached out to auto recyclers, so the sort of the end of line kind of thing, and people that recycle parts and plastics and things like that, and how they could apply them. And we even pulled a tier one into the team as well, tier one automotive supplier. So we had a nice broad cross section of the industry. In our study, we had some really key findings. That one is that there's an enormous potential for 3D printing within the collision industry around spare parts. Could help with supply chain issues, could help with special tooling, things like that. But we also discovered there was a really big lack of understanding of what this, how this could impact the business, where it could go, what materials were available, technologies, and all that. When you talk about these technologies, we talk about 3D printing. Many people jump right away to the hobbyist printer, or the one that their son or daughter is using to do a robotics project with, or something like that, right? And as I said in the beginning, I think we're drawing a line. We use much more industrial grade equipment than that. We also kind of sadly discovered that this is really highly unregulated, and that there are folks out there that are printing parts on very low quality printers and selling these to repair shops that are really unknowingly buying really inferior parts. And we actually purchased some of these parts. Pictured here is one of these parts. You can see it's warped a little bit. If you could zoom in closer, you would see the really, really poor quality of this part. We bought this part. Intentionally, we bought it, but we were just blown away by the fact of how poor quality it was. We're also learned a lot about, the potential around specialty tools, jigs, fixtures, things like that, to actually assist in the repair in the shop, the potential for doing that. And I'll show you an example of that coming up. But overall, we found a lot of support from the industry. There was excitement, and this report did get quite a bit of recognition globally once it was published. So we thought, we have to continue on with this more than just a study. We have to start pushing this out and figuring out how to fix some of the problems with the industry to help apply these technologies. So we met with some industry bodies and regulators, and really found a lack of understanding of the technologies and an unwillingness to take on the role. We had others that wanted to generate member paid authorities, which we were not in favor of at all. We're like, look, this is an industry problem. We're not going to make it a club that you have to pay to belong to fix these problems. The problems need to be fixed across the industry. We were running into issues with alliances in the industry, that certain companies are aligned with certain governing bodies, and there was not a real desire to mix across that. So we just kept, unfortunately, hitting dead ends as we were trying to address this. But being the type of people we are, working on the sort of the cutting edge of technology, we don't give up easy. We're determined not to fail. So we really used the report to generate a framework for a new business. We went through it and we said, okay, let's adopt technology that the OEMs are starting to use. Let's look at the same printers. Let's look at the same materials they're using. Let's partner with the right people who are involved with these technologies and work together to provide these solutions. Let's prove to the industry that these solutions are as good as other parts that are supplied with traditional processes. And we thought the best way to do that is to start doing some applications and share some success stories. So we generated the company. It's almost a year old now, called Auto Additive. We did examples of a tool used for in repairing bumpers, and it's called the push tool. So it's a 3D printed tool, and it can be used. Both ends of the tool have different shapes on them, and you use to push bumpers out. We generated actually a metal 3D printed repair jig for repairing tabs. We have printed several different headlight tabs that could be welded on or glued on in some fashion, and working on testing those today, and even generated just for fun a specialty item. This was a commemorative ring for a conference, right? Just to show people and demonstrate the power of the technology. So a lot of this has all come from the creation of a council, an advisory council for auto additive. And so we reached out to a couple of the same players that were on the other group. So Mario Domolsky from the Boyd Group and Dallas Martin from Toyota both agreed to be on the advisory council. We've also now said, okay, how do we run this business? We have data, we need security around the data. So we invited Lior from Assembrix to join the group, blockchain technology and software for securing some of the data transactions. We have Marion here from an automation company. HP is once again participating. Aaron DeLong's on the group. We have Dr. J. Daniel from the University of Derby, the supply chain expert. Gerald, who you'll hear from in a little bit here from the insurance industry, was kind enough to join our effort, and ICAR again is once again on it. We also have a member here from a sustainability organization. So it's been pretty exciting for us to build this group and to start this company and to really look at how 3D printing can affect this auto repair industry through reducing costs, through eliminating supply chain issues, for quicker turnaround time for parts, and better sustainability overall for the entire industry. So with that, thank you for your interest in joining me here. Appreciate the time. Got to talk to everybody, and I guess from here now we'll close down my sharing and open this back up for questions.
Great. Well, thank you, Jerry. I'm sorry about that. Thank you, Harold. Great information. I had a whole list of questions, and I think you answered almost every one of them. Great information. I was really impressed with the ability to eliminate waste, because it's an additive process as opposed to a destructive process, or a reductive process, I guess. It would seem to me that the OEMs and manufacturers would be really attracted to 3D because of that cost saving. Is that what you're seeing in the industry?
Yeah, we are. It's becoming more and more interesting to them. I think in the last several years, it's opened a lot of eyes. But previous to that, if we were to back up like 10 years, it was being used as a prototyping tool, and a lot of folks really couldn't see how you could scale this up to production volume. Right. If you took the case of like an F-150, Ford makes, I don't know, a million of them a year, for example, right? Somebody scratches their head and goes, how are you going to make a million parts a year to supply this vehicle? Well, maybe the mainstream vehicle, that's not the right application, but as you look at that vehicle, it's broken down into different trim levels, an XLT, a Lariat, and other versions of that vehicle, which are much lower volumes. So what makes that unique from the high volume base platform? There's a ton of applications in that space that 3D printing could do, and some things, a million pieces may not be out of reach. It just depends on the size of it and what the requirements are for that part. So the industry's evolving, and I think it's getting more and more attention all the time about how can we apply it? What can it save us? How can it help us? Those sorts of things.
Focusing more in the collision repair space, what do you think the impacts are going to be, and what's the time frame for that?
The time frame is now. This is starting. We've already started making repair tabs for headlights, and what the impact of that is that we can reduce waste to landfill. Headlights that have 2 or 3 broken tabs off them or whatever, as long as the rest of the housing is intact, it can be repaired. These materials have equivalent properties that are as good, we're finding, as the original properties. We are going through testing and validation on that to prove that to everyone right now. But the time is now, or in the very, very near future, to start to roll some of this out.
Do you see applications beyond the headlight tabs?
Oh, yeah, absolutely. Absolutely. That I've talked about this in my previous career, that if you want to know what you can do, go out and open the hood of your car, or go out and sit in your car and look around it, right? And identify plastic pieces that are, generally smaller. I mean, the technology can make bigger parts, but the economies of scale are difficult on bigger parts. So as you look around at smaller parts inside the vehicle, and especially things that are not Class A, things that are not especially visible to your eye, the brackets and things like that are absolutely doable now. Class A surfaces are coming. People are working on it. There's some applications that are coming out that are Class A surfaces. So I think there's a lot of opportunity for that going forward.
Great. Gerry Poirier from your group is also on the call. Gerry, you've got many years of insurance experience. What's your perspective on the applicability of this in the collision industry?
I think it's got a big upside. And the reason, if you look at the collision industry now, the insurers are worried about the total cost of repair just climbing. And along with that, you see more total losses. In many instances, let's just take an example of the headlight. Many of the headlights are $3,000 or more. And if you think about that, and if it's a way to repair that safely with quality, then that's a huge savings, not only for the insurer, but to take those cars out of the total loss funnel, right, for the repairers to repair, right? Overall collision claims are down. So once again, overall collision claims are down, total losses are up. So if we can change that, then that's a plus for the industry and the insurer.
Great. My question, I guess, is to both of you. One of the concerns that you, Harold, showed was a very poor quality 3D printed part. And certainly, if we're going to use these parts in a production environment, how do we guard against that?
All right, I'll try to answer that one first, Harold.
You look like
Maybe
you're
put you on
taking a
the
breath,
spot.
Gerry, so I was going to let you go.
Okay, you've been talking. All right, similar to almost any other part when you think about it, right? You can get different versions of the same part across the broad spectrum, right? You can buy an OEM part, you can buy an aftermarket part, you can buy a certified part, you can buy a part that's not certified, not tested, anything else currently, right? So for the collision side, right, and the insurance side, certification or third party that is verifying these parts are either made of the same product or compatible is going to be huge. And I think that would take off. But you run into the same problems today. The consumer, can buy whatever kind of part he wants, and you get exactly what Harold showed you, right? Poor quality, things to that effect.
Are there efforts to create a certification body or a process underway at this time?
Well, what we want to do is we want to look in our own house first. If we want to again, as I said in the presentation, we took the business model or basically created a business model from the study, and the study said, hey, nobody's certifying these parts that they're 3D printing today. So we want to do that. We want to get them tested, and we want to be able to provide data to anybody who would be interested in using tabs printed through our process, that here's the data. It shows that it's just as good as what they're doing today. And it was crazy during some of our research. We found that in the case of like a headlight tab, there were people that were using cardboard and chicken wire, and they were putting it together, and they were putting epoxy in, and they were creating a tab and drilling a hole through it. And we just went, wow, clearly what we're doing is better than that solution. So I think that's what we want to do, is sort of set an example for the industry, that you can have a good quality part that has some data behind it to prove that it's quality, and it can still be at a reasonable cost. It doesn't have to be really expensive. So um, that's, I think, the best way we can address it for right now, until we can get more attention on it and perhaps start to create some certification bodies around it.
Yeah,
Great,
either a
thank you.
either a certification or some data, right? If somebody wants to see the data behind it, that's just as good.
Okay, great. Thanks. We have a lot of questions being asked by our attendees, so I'm going to invite Stacy Phillips, who's CIECA's marketing director, to moderate the questions and ask them. So Stacy, take it away.
Sure, and some of this has been covered, but if there's anything you'd like to expand on, our first question is, our attendee is curious whether there is any data available about the average cost difference.
We didn't study that a whole lot at this point. I would expect that would be something we'll work on as we go forward, though. So I apologize, I don't have anything that I could share in this format with you.
That's okay. Our next question is, can you expand on any of the testing processes comparing the properties of a 3D printed part to a traditional manufactured part, and what goes into the process?
So some of the 3D printed parts we were finding, and early on when we were still studying uh, the impact of 3D in this industry, was that many of them would tear apart very easily, and they would separate on a layer line, right? So as you're building this part up layer by layer, you have these distinct lines between the layers, and if you started to put stress on them, they would separate the tear across those layers. So the technology that we landed on does not do that. It has equal strength in all directions. So that was a big benefit to that technology, that we can start to get a lot closer to material properties of a traditionally manufactured part. And so as we move forward with some of our testing and validation on this, that is our goal, is to be as good as that originally manufactured part.
Thank you. And our next question is, as a repair shop, when can repairs expect to be able to purchase 3D parts?
Well, I think that's very, very soon. So we're working with signing on supply partners right now, and I think you just can keep an eye on our website for information on that. We, as Auto Additive, will not directly sell to shops, but we will have supply chain partners that will be the distributor for these parts, and that's beginning to happen right now.
Thank you. And you had mentioned about OEM parts, and our next attendee wanted to know how OEMs view your initiatives to supply repair parts.
Well, we have a member of an automotive OEM on our team, Dallas from Toyota, and he's super supportive, embracing it. One of the things that the importance that they drive to is the whole data, like Jerry mentioned, having the data that proves the quality of the part. That's one of their biggest concerns. They don't want inferior quality parts going out on their vehicles.
Yeah, I think to
Great.
add to
Thanks.
that, well, I
No,
think to
go
add
ahead,
to that,
Jerry.
yeah, I think to add to that, Harold, is a lot of times if those cars can be saved by those and not totaled, right, by those parts, the CSI on the OEM increases because what the OEMs are seeing a lot is that when the car gets total loss, sometimes they don't go back to the same manufacturer.
Interesting.
Great. Yeah, great insight. One of our attendees is associated with collision repair education and was wondering how can the panel, how can he or she find out more information, and can the panel please supply resources to learn more about the impacts of this technology on the industry?
I would just offer that person to reach out. They can reach out to you guys and they can be directed to us, or they can, we have contacts on our autoadditive.com website, where we'd be happy to have some discussions with those folks.
Great. Well, we'll make sure to include your email addresses for all of the attendees. Our next question is, what 3D scanning technology, for example, structured light, is most likely to be used in body shops when creating a CAD file to be printed?
So I don't think at this point that we're going to be looking for body shops to do scanning and create files for us. We are working on generating a database right now of the most popular repair items that we think are 3D printable. And so I think that's the way that we'll be proceeding for now. We won't be putting that on the shops. But what the shops can do is communicate pieces that maybe they're having a hard time getting, that they would want us to take a look at, and then we would take it from there as far as identifying the part and generating geometry around the part and building it and testing it and things like that, making it ready for use.
Okay, thanks. And our next attendee asked, have you reached out to Intertech as a possible source for certification?
It's funny they mentioned, because Intertech is one of the companies we're working with to do testing for us right now.
Thank you. And our next question, where can I get my 3D printed parts OEM certified? How do I start? I'd love to become a supply partner. I already 3D print many auto, plane, boat, and motorcycle parts. So we can share information with the attendee, but is there anything to help get them OEM certified, the parts that you can share?
I think that would be a conversation probably best had offline. So again, if they want to reach out, we would be happy to talk about that.
Okay, thanks. And then when testing, this is a comment, when testing, the committee may want to consider testing at the vehicle level in addition to the component level.
Understood. Yeah.
Unless there is sufficient vehicle level data that can be level tested, particularly related to components that affect safety.
100%. Agreed. Thank you. So,
And Jerry, was there any other insight that you'd want to share from your perspective about 3D printed parts that you haven't been able to share yet?
Well, we talked a little bit about liability issues. Pretty much the same liability issues you would have with any part that's out there. You know, you could have a defective design. You need to make sure that if you're doing these parts, that your insurance covers it. But it's more similar to any other part that's out there if you're deciding to print it, or if you're using the part and there's a defect in it. So there's really not a whole lot of difference in that category as far as liability goes.
Okay, thank you. And we did have a comment earlier on about the concern about the time it takes to print the parts. Are there any comments regarding timing?
From whose perspective, Jerry's or mine?
From either of yours, anything about that? It was a comment from one of our attendees.
Okay. From my perspective on the technology side, the time it takes to print the part, I think we're showing that that's very little impact. It's the time to print parts are just reducing all the time, and it's getting faster. Major highly used pieces probably will stock a small inventory of them, but I don't expect us to inventory a lot. I expect us to print mostly on demand. I don't think print time is going to be a big factor because of the machines are so fast now.
Yeah, you might be referring to the smaller machines that take a little bit longer, but most of the machines that are being used now are larger ones that are much faster.
Great.
Harold,
And
sorry, Stacy. When the 3D printing machines, the commercial grade machines, do they have to be set up to go from one type of part to a different, or can you just feed in a series of CAD files and they'll just print whatever comes up next?
Well, it's yeah, that question, I guess, could be answered from a couple of different perspectives. So in the example I showed early in my presentation, I showed a picture of 140 basically different parts. And all of those parts simply were fed into that build space, organized so they weren't touching each other, and printed all together at the same time, right? So from that perspective, not a lot of data preparation would be required. But as you grow, you start looking at other technologies that are better at certain things, and we'll just jump right across the other side to metals, right? So if you had a metal bracket, a little different environment printing metal parts than it is some of the polymer parts that I was using in my examples, where it may take a little bit more of a setup and a little more specialty type application to print those than just the general ones. Does that help, Paul?
Yeah, great. Thank you very much.
And I was wondering
Stacy?
I was wondering
Go
if
ahead.
the two of you could kind of share your insight looking out, let's say a few years down, 3 to 5 years in the future. Where do you think the industry is going to be in really regarding 3D printing?
Well, I could start with that. And I think as the automotive OEMs are embracing the technology more and more, they are going to be getting into more production parts. So there's certainly an application now then, so you would be able to, they would be able to certify companies that are allowed to print parts, replacement parts for them. So this sort of jump into the repair business is a lot easier then. You're eliminating a lot of supply chain issues to being able to 3D print parts essentially on demand. I think that the technologies are going to continue to improve. The materials are going to continue to improve and be more robust. As all of that starts to happen, it drives price down because it's the chicken and the egg thing. The price will come down when the volume comes up, and the volume will come up when the price comes down, right? So they're going to kind of start squeezing each other and meeting hopefully a little more in the middle, which will then open the technologies up more and more to others. And I think if we look beyond that, question that's often asked of us is, am I going to have to put a 3D printer in my repair shop? Well, I think it would be more like, do you want to put a 3D printer in your repair shop? Because I think in the future, the technology will become such that might be possible for you to do that. I mean, it's possible now. Would it make good business sense for you now? And that might be questionable, right? But in the future, it may make great business sense, right? You may put a printer in. You may, in putting that printer in, you may get access to a database full of parts, and you may be able to go over there and say, I need this part tomorrow. It's broken. Find the SKU number for it and download it and print it in your shop without having highly trained technicians available to run the machine and do all the troubleshooting like that, right? But again, that's kicking the ball down the road a few years. Right now, I think what we want to focus on the most now is providing or generating that database of parts that are the most applicable, most needed, most usable in the industry with these technologies, and then allow companies to order and get a very fast delivery on those parts. with some assured quality.
Excellent. Thank you for that, Harold. Anything you'd like to add, Jerry?
I think Harold hit on a lot of it, but I think from a collision repair perspective, just think if you don't have to wait for that part, right? If somebody comes in, your cycle time decreases hugely, your efficiency increases by quite a bit. And just like any other tooling, right, when you think about it, how the industry's evolved, right? You're buying riveters now, you're buying different welders. This may become part of your tooling, right? That you can make these brackets rather than having to wait for the supplier down the street to bring it to you. So just think about how more efficient you would be as an organization.
Excellent. Well, thank you both for sharing. And Paul, we don't have any other questions at this time.
Great. Well, thank you, Harold. Thank you, Jerry. Appreciate your time. Great information. I think it was a very informative presentation. I very much appreciate it. This presentation has been recorded and will be available later today at CIECA.com. I would invite you to check CIECA.com for a schedule of future broadcasts and to watch recordings of past webinars. Links are available under the Meeting and Events tab. And as we wrap up today's presentation, we invite you to join us in Nashville, Tennessee, September 23rd through 25th for Connects 2025, CIECA's annual conference. The theme of this year's conference is Insights to Innovation, the Future of Collision Industry Technology. The conference features a day and a half of presentation, includes a tour of the Nissan assembly plant in Smyrna, Tennessee, and you can learn more about it at CIECA.com/connects. And with that, thank you, Harold, and thank you, Jerry, and that concludes today's webinar.
Thank you, Paul.
Thank
Thanks
you.
for having us.